Hello, everybody. Welcome to Spatial Ecology's Geocomputation and Machine Learning for Environmental Applications course 2024. I'm Tushar Sethi. I'm one of the two directors at Spatial Ecology. Giuseppe is the other director, and Giuseppe founded the course about 16 years ago and formalized it under Spatial Ecology about 10 years ago. So we've been running this through Spatial Ecology, which is based in the UK, for about 10 years now. Welcome. My background is in environmental engineering and management. I oversee course operations and communications. This year we have as instructors on the course Giuseppe, Antonio, and Francesco, who will all introduce themselves in due course. I'll quickly go through an administrative overview with you, and then hand it over to Giuseppe to continue with the introduction to the course. So on the 25th of March, you would have received an email from Giuseppe, which details various points you need to look at. There are links to several web pages as well, and instructions. I'm going to now share my screen. Oh. And I'll walk you through some of the key points that are needed for the course. Please give me a moment. Can you see my screen, Giuseppe? Yeah. All right. Sorry, Zoom. My screen's gone now. 1 second, please.
Still black indeed.
What's happened? Resume. Isn't working. Zoom did something funny. 1 second. It says, let me start again. Can you see it now?
It's still black. It went in sharing, but it's black.
Yeah. It says resume share, but it doesn't work. I'm wondering why.
Maybe sharing the full screen.
It never happened before. Hang on. Stop share. Strange. Share screen. I'm sharing the full screen. Screen sharing is paused.
Start screen sharing, yeah.
Sorry, this is. We tested this before joining the call, and now it doesn't work.
Okay, now you can see yourself. I think mine is working.
Right.
Okay, try again. Or if not, just go by.
Okay, why don't you open up your screen, the syllabus.
The syllabus. Okay, yeah.
Screen, please, and then I'll talk through it. I'm going to stop sharing mine.
Okay.
And let me just take this across so I can see what I'm talking about.
Yeah.
Okay. In Giuseppe's email of the 25th of March, he would have sent you a link to this course webpage. This is the course syllabus, as well as the course timetable and student roster. So at the top, you have all your class times and some basic details about the course. And also we have a list of instructors and a student roster. So you can see all your class peers online on this webpage. If you haven't submitted your photograph for this roster, please do so. If you don't want to submit a picture, you can submit an animated image of your choice. At the very bottom of the page, you will be able to see soon the whole global representation of this year's class. Every year we get students from all around the world, so it's quite interesting to see where your class peers are coming from. When you access any of the course pages, whether it's the main website, the main course website, or this course web page, please open your browser in incognito mode or delete all the cookies, because when we update these pages, and we will be doing so regularly, you won't be able to see the updates if you've got cookies that are drawing from the previous versions. Also, please set up Discord for all communications. We're going to be using Discord throughout the course to communicate and chat and send messages on a regular basis. I think most of you have set up Discord already. If you haven't, please go ahead and do so. Giuseppe's got that screen share up right now. Classes will be recorded like they are being today. All the recorded links, all the links to the recordings will be posted a few hours after the course. Please keep your videos turned on. This helps keep the class interactive, and it also keeps you engaged. Zoom fatigue sets in very quickly, and you may not be able to follow the material if your video is turned off. There is a tendency to lose track as we progress from topic to topic. So keeping the video on not only helps you, it helps your entire class from remaining engaged and encouraging interaction as well. We do encourage you to interact regularly throughout the course. It is part of the learning experience. Please, you don't have to feel that you are going to be interrupting the flow if you do that. For any out-of-class study, we recommend 20 hours per week of homework time, if you want to call it that. You can work with your own data sets. The most important thing is when you're outside the class, you practice the command line approach. For those of you who have registered for the Matera workshop, the hackathon week in Matera in Italy, which runs from the 10th to the 14th of June, please send us some proof of your accommodation or travel plans, just so that we know you're coming, because we will have to finalize the event at our end in terms of booking the classroom, etc., at the University of Basilicata. There will be a project due at the end of the Matera workshop, and that usually takes place during the last 2 days. For those attendees who are present, who are on site in Matera, they will present in those last 2 days, and those who are unable to attend, they can still present their class projects online during those 2 days, and we'll assign slots for everybody. You do have to present your final project in order to get a course completion certificate. If you need to see project examples for course projects, there are some. Giuseppe is scrolling through them right now. At the bottom of this course page, there's some links which show you there's Matera and there's Sweden as well from previous years, and there's some course project examples over there. The week following Matera, we've got a new format this year. Some people are staying on in Matera. So from 10th to 14th June, we have the workshop, the hackathon. We have a hackathon follow-up in the following week, which is from 17th to the 21st of June. And this is to enable people to work on individual projects, but in a collaborative environment. There won't be any teaching or instruction. It's just to give people an opportunity to sit in a classroom at the University of Basilicata together, continue to work on their projects and consult with each other and engage with each other as needs arise. So you have the option of staying on if you wish to, but it's separate from the course. So this doesn't fulfill any course requirements per se. And accommodations for Matera are also provided. Accommodation details are also provided on the website, so you can go there. Giuseppe, please, can you pull up that page as well? We have some special deals with the hostel, and there's some other recommendations given there as well for people to choose from. Then
I have a question about this
yes.
Extension
Go
week.
ahead.
So do we know, like, usually how many students are staying? Like, because I don't know how useful is it, and in the end, if I'm and is it for my own project, or is the extension of the project that we work on in this hackathon week?
I can jump on this.
Go ahead.
My name is Giuseppe. I'm co-hosting and co-organizing and teaching all the courses in spatial ecology, and I'm a founder of spatial ecology. I will be in charge for the geocomputation. So concerning the final requirement of the project, or the final project, every student can bring whatever they want. Okay, so it's up to, we are not giving to the people the course, the subject, but everyone can work in his own PhD, master thesis, or whatever. Okay, so this is able to apply all the techniques that we are learning to your study case, to your data. And also the different assignment that we are going to have during the course, they can be tweaking, let's say, with your data. In other words, if I give your 20 raster and say, make the average, and you want to use your 20 raster, it's fine, okay? So we are not picking these circumstances. So the second week in Matera that we were pointing before, so the first week we have around half of the people already signed, around 12. I think they will be coming 15. And for the second week, there will be probably a bit less, because not everybody can join the second week. And so you can expect, I think, like 7-8 people working together and having kind of strong interaction. The week in Matera, the previous students are really like it, this kind of environment of working together, because there is a strong interaction between the teacher and the students and everybody else. And they gain quite a lot. They're very happy that they come back with let's say, with a full PhD thesis, no, but with a big part of it. Okay, so feel free to join and stay longer. Material is very pleasant. It's not very high cost in the yeah. You can sleep in the hot hostel for 26 euro per night, or find accommodation that are in their range between 30 and 40 per night. And for food and eating, you can think about 20 euro per day for having some food.
Yeah. Okay, thanks.
Okay, Tushar, back to you.
Yeah, I just have a couple of concluding points. After the optional week, on the following week in Matera, the second week, there is a Geo Open Hack 2024 big geospatial data hackathon with open infrastructure and tools being held in Austria. And that is, let me see what the date is.
24.
That would be on from the 24th to the 28th of June. If you are interested and haven't registered, please register separately for that event. The links are provided on the Spatial Ecology homepage. And with that, I will hand the screen back to Giuseppe. Thank you for joining us, and I wish you all the best.
Thanks, Shar. And due to that, I'm sharing this webpage. Let me add in a few information about this GeoOpenAC. Can be seen as a continuation of the spatial ecology courses and going one step further in the cloud computing. So you will arrive with a full set of tools that we are going to provide during the course for the geocomputation and for the machine learning. You will be able to working quite well in your laptop without any issues, but you will soon reach the RAM limitation and the hard disk limitation of your laptop. If so far you didn't reach it, with the tools that we are going to give it, you are going to say, okay, I can't not anymore doing any computation because my data are too big, my model is too complex to handle such a kind of data. So we were thinking from several years to organize an advanced training, and this is the opportunity that come up during this winter, organized with the IIASA, such a course. So it's not going to be a replication of the course, of the spatial ecology course, but a following up that go one step further. People that they are going is advanced level, so you can see that is an advanced level. So, but people that ending all the full spatial ecology course with presenting their work, they will have the knowledge to be able to join such a kind of course and getting all the benefit for this. We will also here use work in open source infrastructure. So we will have 3 working days working in the HPC. That quite often we will have a guest account for HPC, but most of university nowadays they have the possibility to acquire for HPC. So you can join later on your HPC from your university. This is for the 3 days, and then we will have another 2 days where we have open source access to cloud computing with the OpenEO software, with the Pangeo software. So these are more cloud oriented than the previous 3. So feel free to go through the course organization and so on. Over here, you can see all the syllabus, and maybe you can see that are following up the same kind of structure that we are giving in the syllabus of the spatial ecology course. And feel free to reach me in particular if you want additional information. Over here in this webpage, you can have all the information for registration process and so on. And we have been sending also, you can find in the spatial ecology, as soon you enter, you have there the link. Okay, so let me go through the slide that I prepare. So I'm a research scientist at the Yale University, as I mentioned, founder of spatial ecology. And I can say that I'm a forester by training, a geographic information scientist by training, but then I'm becoming computer science by trade. So just trying, learning by myself and following YouTube video, we were able to establish good knowledge that was in the process to sharing with the others. Coding in different programming language, in Bash, in R, in Python, GDAL, in pktools, in Grass, and try to get as much as possible the best of each programming language. I always say that after few programming language that the fourth one is becoming easier. It's like talking spoken language, foreign and spoken language is the same concept. In terms of teaching, we will go through most of the language that we are going to listed over here. We are based our work mainly in Bash and Python. We also running courses in R, but due to that university, and most of you already use R, we focus more in Python due also to his capability in dealing better with the machine learning application that later on Antonio is going to cover. We will start the course with Linux, especially with a classical black screen terminal that is going to be your master master home place where running scripting computing procedure. And we will use a bash language to run AWK for massive geodata text, more than geodata, text processing. AWK is an old programming language, but it's still one of the fastest for text manipulation. And especially if you have a gigabyte of text, you will see how easy it is to select line and to select column and so on. Then we will move to the GDAL, OGR, PK tools that are all these three are for geoprocessing under the bash environment. And we will have also an additional 3 days on Wednesday, where we are going to have the GRASS software implementation. Yes, teaching and implementation. So we will have a full package of the geocomputation. Then after having, let's say, the geodata preparation in your hands, I will give the floor to Antonio for the machine learning implementation. So it's a following up of the geocomputation, because with the geocomputation, you prepare all the layers for the machine learning model that Antonio is going to learn. Antonio is going to learn a very typical machine learning technique, but is giving you an overview also about, you know, training and testing, how to splitting the different data set, how to consider for validation, different accuracy and mean square error, when do it supervised and supervised classification. So he's going to cover all these aspects of classification. Rather myself, I will focus more in the geocomputation. In the middle is going to be also Francesco, that is going to be cover a bit of GeoPython, so application under geographic analysis with Python, and later on Francesco is going to talk a bit more about his part. So we will follow up with knowing each other after the two teachers, Francesco and Antonio, also finish up. So I will bring back to this slide when you start to present yourself. In terms of, we have to keep in mind when we coding and when we are approaching a new coding procedure and a new working coding. So quite often, I always share this slide of your computational work that you have to think when you're working and why you do scripting procedure for the for your work. So far, or some of you have already engaged in the coding, in general, in the programming coding learning course. And when you do the coding, you have to focus on the different aspects, such as in the beginning, you have always, you know, working with raw image, that can be data, can be different kind of climate data, biodiversity data, economical data. So over here, you have a lot of stratification and standardization of the data, including cleaning, filtering, harmonizing, pixel, in our case, pixel resolution, extent. So over here, all this one is the geocomputation part that is going to be, sometimes it's very long and tedious, especially when you have to cross in different data set coming from different sources. And here is where I will play the role in preparing this operation and using GDAL and PK tools to do this operation. Then you have a third part that is data statistical physical analysis, where you have the modeling part, okay? And then when you're running the model, you have the final operation with the final output with graphical table, summary, website, and presentation. So all this process, when you do the clicking procedure, you do only once with the hope that you don't do it anymore because you don't want to click again. So with the programming skills, this procedure need to be run several times until you reach the perfect model, or that the model cannot improve it anymore. Also because several of the errors that you don't see that are coming from the geocomputation aspect, they will show up in the learning, after the learning phase, the training phase of the model, and with outliers or with the error in the model, very huge discrepancy with your training and testing and so on. So this one can be due to the model that is not fit, but can be due also that in the geocomputational part, there is still some outlier, some no data labeled correctly that are carry on in the process, and then they make mistake in the machine learning, so in the final result. So that's why you need to go back several times. So going from the beginning up to the end in a dirty and fast way, and then go back and improving the model. Go back the model, the full scripting procedure. So I always say that the different script need to go in cascade in order to be processed the full data set again from here up to the end. And this kind of interoperability and this kind of flow, you can have it when the different languages, so GDAL, Bash, Python, R, they're really talking together in order to have the full flow. And this kind of maximum interoperability between the programming language you have inside a stable operating system such as the Linux. Indeed, all the different server, they use Linux because it's very secure, it's very extremely stable and reliable, as you know, no virus, so very rare that there are viruses. They can run the open source, they can run in Unix, Windows, in Mac, also in the phone as Android, but the best result, they are really inside Linux machine, because the developer, such as Francesco Rovergen, first they work in Linux, and then if they have time, they do the Windows version. So it's always convenient to stay in Linux, because you get the first, let's say, the first better accuracy inside the Linux, the best version and the updated version. In terms of application, there are thousands of free programs. You can see there is always the brother in the private software. There's always the brother in the open source software. You can say alternative to PowerPoint, and there's coming up alternative PowerPoint in the programming language. There are extremely versatility. They have minimum hardware requirements. They can run in old PC. So if you have an old PC with 8 GB RAM, or even with 4, just full installation of the OSGeo Live, I will point to you where to have the downloading, and you can do you can have a very old computer becoming fastest than so on. You have the maximum freedom. You have the maximum freedom to modify software, to modify programs that you see online. You have a lot of feedback from user mailing list and so on. And in the end, it's quite frustrating. You will see it's going to be frustrating sometimes, but then you will get a lot of freedom and a lot of fast operation for your application. And we will focus quite a lot in really understanding how the computer works, in terms of not only for the syntax, let's say, or the programming, but also how and why a for loop is better not to do it rather than using another kind of application. Okay, so you can really have an understanding of the code, but also the machine, how it works. You can get a lot of help from mailing list. You can see probably already some of you are already in the R mailing list, machine learning Python mailing list, and so on. These are very active, so feel free to reach them and to subscribe if you didn't, in order to get familiar with this. In terms of process, you will learning also, how to save it, your file inside to the RAM, what does meaning, and understanding the RAM management, using more CPU, one CPU, and why the CPU you can use many, but then the RAM is only one, so you have to consider all this one. Hardware resources, how to storing in temporal file. There are some specific folder in the cluster that quite often are considered like a kind of cleaning, automatic cleaning after 20 days. how you can use the TMP inside to the cluster, and so on. And, least but not least, enjoy the life. In the meantime, the PC is working for you. So this is the main point, that you need to have you have to use your time to build up the scripting procedure, and then let it run during the night or during the holidays, Christmas holidays, summer holidays, as the best if you want to run high performance computing, because nobody's using, or at least less people are using. So it's very promising to be able to schedule in a clever way your scripting procedure. We will focus in the architecture of our kind of working, is going to focus mainly in this way. We will have our Linux PC in the center, where the Bash language is going to communicate with all the different software. Okay, and we will have in this area AWK for text manipulation, all this part, for the geocomputation part, are also for sometimes a bit of geocomputation, but also for the machine learning, and the Python for the machine learning that Antonio is going to cover. There are some software that we will not see due to the time, like, for example, ImageMagick. But also this one, if you understanding the coding behind, you will get after a few days of working with that specific software, and so on. So it's going to have a new way of working under this system. There are nowadays a different way to work, rather than having the Bash language in the center that is calling all the different language. You can have also R in the center, and even Python on the center. All of them are fine, but we will focus more in the first one, because especially if you want to migrate into HPC, you need to understand it quite well, the Bash language, in order to working properly in setting all the different operations with Python and with R. So this is the full overview of what I'm going to teach, how the course is organized. Now we give the word to Antonio, that is going to present his part with the machine learning part. I stop my sharing, and welcome, Antonio.
Hello, guys. Nice to meet you all. Let me share my screen very quickly. All right. You can see the screen properly?
Yes.
Excellent. Great. Yeah, thanks, Pepe. So are we doing introduction first? Like introduction of ourselves?
Yes, please, from yourself. Yes.
Okay, yeah. So my name is Antonio Fonseca. I have a PhD in neuroscience. Although my PhD is in neuroscience, most of my work actually relies on developing machine learning methods, right? And therefore, that's the connection that we have between like what we're going to be doing like in geocomputation and my area of expertise, which is actually machine learning, right? So Pepe already has very nicely motivated the use of machine learning as being a really powerful technique that we're going to be using to try to leverage some knowledge, right, about these massive data sets that we have nowadays, right? But let's take one step back and see like where is the state of the art of machine learning nowadays, right? So as you know, right, machine learning has been like a real game changer in terms of like how we learn to extract meaningful information of data, right? And doing insights, right? Like make good use of that powerful technique. So for example, I'm not gonna ask who of you here already has used ChatGPT, because that's basically the same thing of asking if you have used Google before, right? So like on the left, we have ChatGPT, which has been exposed to all the text information that's available on the internet, right? To try to leverage some knowledge to answer to your prompts, right? Which your prompts usually is like some specific question that you have. Since ChatGPT, many other tools that are based on the same technique, which are neuronal networks, like a specific family of neuronal networks called transformers, which we're going to be discussing like very briefly later on in the course, right? This type of framework has more recently been extended to like video generation. So probably you guys have heard of Sora, right? So like you give a prompt and this thing generates not just a static image, but actually full videos, as you can see like illustrated here in the middle, right? And then moving to a different field, we have on the right side, protein generation, right? So like now you're capable of giving a sequence of a protein, right? Extract in really high accuracy what's the structure of that protein sequence that you have generated, right? With like huge implications for drug development, right? And with the hopes that this type of technique might improve our capacity of developing more specific and targeted drugs, right? Well, but enough about like what machine learning has achieved in general, right? Like how can we use these techniques for geocomputation, right? They are the basic ones, right? So for example, I think that the first applications of machine learning to, for example, satellite image has been towards mapping streets, as you can see on the right side, right? Which has huge implications for example, emergency management, right? It's important for you to learn how you can find the shortest path or like the quickest exit from like an area of like danger for example. Here we have like some analysis of like the limitations of properties, and in this case, like if you're looking for a specific characteristic, if there is a swimming pool in the property or not, right? Those are simple computer vision tasks, right? More recently, people have been using this type of techniques also to try to make predictions about, for example, biodiversity, right? So for example, these guys in this paper, they're making predictions about the dominant trees species that you had in different regions according to like what were the features associated to those regions. By features, we're going to be discussing that in more details. Usually it's related to like what's the elevation, what is the latitude and longitude associated to that coordinate, right? And many other factors, like if there is water available and so, right? Those are all features that usually we learn something meaningful about how to take them in consideration when making a prediction, right? For like a variable of interest. And one of the data sets that we're going to be using a lot is exactly like how can we leverage collected features, right? To try to make predictions about the tree height, for example, how tall are the trees that are in these different regions, right? And we're going to learn how we can build an architecture or like a neural network to make such predictions. Okay. And with a bit of luck, I would say, I intend to do one tutorial for you guys in the in-person week that we're going to have in Matera, which is about this latest technique, which is a collaboration between NASA and IBM, where they are expanding this type of framework for like satellite image classification to like an open map, right? So like you could choose a region of interest and make several types of predictions according to like some variables that you have available by the data set that they have created, right? So these are the different family of machine learning models called foundation models, right? Which we are also going to be discussing later on in the course, but like really like latest techniques that just came out in this field of like geocomputation using large machine learning models. Very well. So let me tell you a little bit about the things that we're going to be discussing in the course, right? So like, I'm going to take you guys from like the very beginning, which is like how machine learn it's basically implemented by using neuronal networks, right? So here perhaps things become a bit more clear. For example, in my background, how I got introduced to machine learning, right? So for example, when you're talking about neuronal networks, not a lot of people think of that, right? But the word neural, it's actually coming from how the first people who start to trying to understand how brain was processing information was to come up with this little framework, which like later on got the name of perceptron, which was simply trying to mimic how people believed that neurons were processing information, right? Later on, like, of course, these took off like in a completely different directions where people were no longer trying to learn how the brain was processing information, but realized that this thing by itself was actually a really powerful computation engine, right? Of course, there are quite a bit of limitations about the perceptron as it is, right? But this thing really scales up to be like a really powerful approach when you start to make stacks of perceptrons, right? Which is where essentially we move from like having a single perceptron to multi-layer perceptrons and what we basically know as deep neuronal networks nowadays, right? So, of course, going from this simple model to like this much more complex and no linear representation, right, of like how you can leverage knowledge, sounds intuitive that you're going to get greater capacity, but then you have greater challenges with that as well. So like, how do you train such things, right? So we are going to be covering how these large neuronal networks, they're trained, all the intricacies of getting these things to work, right? And then essentially you're gonna have the whole knowledge that is the like the foundations, if you will, right, of like machine learning. If you understand this, right, which is like really the backbone, the core of machine learning, you're gonna see that like understanding the latest models that are coming out, right, foundation models like diffusion models and so they're essentially extensions of these principles, right? And of course, once you grasp the principles, understanding specific techniques become much more easier, right? In terms of like what are the specific types of machine learning that we're going to be covering, right? Uh, I hope you have heard of these three main branches of machine learning, right? So for example, when you're talking about machine learning, you're talking about this method that you use to extract knowledge from data, right? But you have three main approaches that you can use for that. The first one being supervised learning. That means that you are going to try to leverage knowledge from the data to make a prediction about a variable that you care. That's being like regressing a value, right? Or classifying like what that data corresponds to, right? Then you have unsupervised learning, where you don't necessarily have a label associated to this data, right? But you're trying to still leverage some knowledge, right? That could be, for example, trying to do some clustering on the data that you have, although you don't necessarily have a specific label associated to it. In reinforcement learning, usually people talk reinforcement learning as being like trying to build a system that's capable of making decisions on the flight. Usually when you're talking about geocomputation, you don't see a lot of application for reinforcement learning, right? So most of the things that we're going to be discussing actually lie on supervised learning and unsupervised learning, right? Of course, I just talked about like potential uses for classification, right? But most of the things that you're going to be covering actually lie on the regression spectrum, right? So for example, from this branch, we're going to be covering like basically all these topics: linear regression, neuronal networks for regression, supported vector regression, or SVMs as well. I think we're going to be discussing random forest or decision tree regression. So we're going to be covering several of these topics here, mostly in the supervised learning branch, right? And with a little bit of time that hopefully, I'm always very ambitious with respect to like the amount of time that we have. I want to give you guys like as much content as I can, right? But of course, we have to respect the pace of the group, right? So like if I have time, I would like to cover a little bit of unsupervised learning, but the priority is to make sure that you guys grasp these concepts at least, which are like perhaps the most important ones for geocomputation very well. Okay? Okay, so like let's put that in perspective, right? I just told you that like we're gonna be focused mainly on supervised learning, right? But like how many of the problems out there in the wild, if you will, actually can be tackled by using supervised learning, right? So Ian LeCun, which is like one of the fathers of machine learning, if you will, right? He used this slide in 2016 to describe the state of machine learning, right? And how these different approaches, they lie in this spectrum, like tools that you can use to solve problems. So if you're comparing machine learning to a cake, he said that supervised learning perhaps is the icing of the cake. So it's this outmost layer of the cake. The bulk of the problems that exist in the wild, right, they actually don't have labels associated to it. They're just like piles and piles of data, right? So that's the actual cake, right? And reinforcement learning, it's the cherry only, right? So it's like it's something that's very specific, very niche, right? And therefore, that's why we are completely putting it aside, right? But if you guys have any specific applications or interest in learning more about that, we can definitely try to squeeze in like one or two, perhaps one lecture, or maybe like a fraction of a lecture, but we can try our best given the interest that the group have, right? But yeah, we're going to be mostly discussing the outer layer of this cake, which is just supervised learning. Okay. Now, I don't know if Pepe covered that already, but like when you're talking about machine learning life cycle, right? So like what are the usual steps of implementing a machine learning pipeline, right? Those are the big six, I would say, right? The first one is collecting and curating the data, right? Which is like Pepe is the reference for this kind of stuff. So like bother him a lot about that, how to organize the data, how to extract the data that you're going to be using. There is the data pre-processing, right? Which Pepe is also the expert on that. And then you have finally training a model, right? This model could be like neural network based, which is going to be most of the things that we're going to be discussing, could be random forest, or even some simple linear regression, right? After you have done that, you test the capabilities of your model, right? So like that's the fourth stage. Finally, you have the model deployment, like how you're going to make this model available for like new data that's going to be coming in your pipeline, right? And then later on, like how you're going to be monitoring changes on the data set and changes in behavior of the model, right? Because we don't have a lot of time, right? Like machine learning is just like one fraction of this course. And of course, we only have like lectures twice a week. We don't have a full semester. We're going to be focused on these three main points. So it's like the data pre-processing, right? Like how we format the data in order to use machine learning to leverage knowledge, right, from the data. How we train these models, like that's the part that we're going to be talking about, neural networks architecture, right? Like things that the influence performance of the model, and how we can fairly evaluate this model, like how this model is performing, right? Now with respect to like the actual applications, right? Like we're going to be doing a lot of coding. I'm going to try to do a mix between like a little bit of theory and then always going on code with you guys, right? I'm going to try to avoid writing code in front of you, because usually we spend way too much time like writing things, right? And less discussing what things actually are. You can very well just look at the code by yourself. You don't need to write the code with me, right? I think the most important is to understand what the code is actually doing. And that's what we're going to be doing. It's like, I'm going to have the code open. You guys are going to have the code open, and we're going to run the code together. That's what we're going to do. And then discuss like what line by line is doing, right? With respect to like, what are the tools that we use to implement machine learning nowadays, right? There are three biggest players, I would say, right, with respect to like environments for implementing machine learning, that being Keras, TensorFlow, and PyTorch, okay? So they have their pros and cons, right? I'm going to tell you that we are going to be using mostly PyTorch. And why is that, okay? I think TensorFlow is great. It's like when you're deploying something that's like ready to be used, I think PyTorch, TensorFlow, it's actually like the way to go, right? But TensorFlow is not necessarily the most friendly for debugging, right? So like PyTorch is still better in terms of like learning and like being exposed to a new technique at the first time, right? So I think that's better. Second reason for using PyTorch, as you can see from this diagram that I'm putting down here, right? You see that TensorFlow, which was initially created and curated by Google, right, has been losing some steam, right? Why that's happening, it's not entirely clear, perhaps because PyTorch is a little more friendly, right? But TensorFlow is losing a little bit of steam, and like most of the resources you're going to be finding online actually correspond to PyTorch, right? So like PyTorch at this point has better documentation and is easier for you to find the resource to help you, right? So I think PyTorch as an entry point, like tool for implementing machine learning, is the way to go. If we have time, again, right, I'm gonna try to give at least one lecture in which we use TensorFlow, just so you can compare, right, like how to use one tool versus the other. But the majority of the things are going to be done in PyTorch, okay? Now, with respect to the background, right? I know that you guys had to fill up a form, right? That basically tells us like what's your degree of familiarity with like some of these key concepts that you're gonna be using. I'm gonna tell you upfront that like if there is something that I think is crucial, right, that you definitely should know, we're gonna cover that together during the lecture, right? So for example, Python, I cannot teach you Python. So like I expect you to come to the course already knowing Python very well, okay? In terms of algorithms knowledge, that's good to have, right? But like that's not essential because most of the things you're going to be able to follow by just seeing how we are running code together, right? Now, good to know, like in terms of like machine learning, what would be helpful for you to know would be like how a regression works, not necessarily like how we implement, but the concepts, right? Because you're going to realize that most of the things we do in terms of like neural networks, they can be very well explained first or introduced as a regression problem, right? So like that's why we're going to follow this rationale here. PCA, which is also another basic thing. Those things, they would be helpful, but as I said, we're going to be covering these concepts together, right? Now, in terms of math, right? Like how much math do I have to know? Like linear algebra, it's going to be like linear algebra is machine learning, right? So like most of the things that we do, they basically stands for like matrix multiplications, extracting eigenvectors and eigenvalues, right? So like these kind of things, I really would like you to know, right? If you're not entirely comfortable with these concepts, feel free to reach out. I have like a couple of like online resources that I could point you to, right? And for you to catch up with those readings before our lectures, because I'm not gonna have time to explain that. I'm just gonna go from the point that you know, like how to use matrix multiplication, how to extract eigenvectors and eigenvalues, okay? Same thing apply for calculus, right? Machine learning, deep learning more specifically, it's heavily based on derivatives, for example, right? Like how to extract derivatives, because that's essentially how you, the type of computation that you're doing when you're computing the loss, right? That you have for the neural network. So I'm gonna assume that you know that. If you're not entirely comfortable, let me know and we're gonna try to find resource that can help you, okay? Now, how do you contact me, right? I don't know what you're going to be using in terms of messaging app this year, but Pepe probably is going to go over that with you guys, and then he's going to let me know later what we are using. My email, it's here, so you can email me here at antonio.fonseca@yale.edu. You can also DM me on Twitter. Like I don't check that as often at my email. If you want to see the things that I have worked on in the past, right? You can feel free to go to my website as well. And like, yeah, and I'm pretty sure we're gonna have plenty of opportunities to catch up later on in May when the first ML lecture starts. Any questions? Is there anyone there?
Hello. Hello, I have a question. Hello.
Yes, please.
My name is Asma, and my question is how much hands-on training or experience we will get during this course?
100%, more than anyone. Is going
Yeah.
Theoretical percentage.
is going to be extremely hands-on oriented course. You can see from previous here, you will always giving the, the code and all the explaining the theory behind together with the code. So then there's going to be one session when you try the code, and then at home you implement that code with your data. So this is the kind of approaching that we are giving. Okay, so that's why we were requiring already a good knowledge of Python. And if your good knowledge of Python is not yet there, try to speed up, because you have 1 month. In April, we are not going to use Python. So we have 1 month to learn more about Python, because the first month in April is going to be focused on Bash. Okay, so this is the
Okay, thank you.
Yeah, I'm gonna I always try to do a mix, right, of like theory, perhaps like in the first half of the lecture, and then just like going over code with you guys on the second half, right, with like some quizzes in the middle to see like what's the temperature of the class in terms of like grasping the concepts that we have discussed, right? But it's gonna be a solid half and a half of the lectures is gonna be like theory and then application. You guys are gonna be doing lots of code.
I have a question.
Mm-hmm.
Okay. Yeah. Thanks for the lecture. My name's Kira. My question is, when you talked about we're going to be implementing a code outside of the class, just mean with our own data, just mean that, let's say you give a lecture on neural networks, then after that session, we find our own data set, maybe our own problem, and we somehow just apply the methods to that problem itself. Is that the idea?
Right.
We create
Yeah,
our own
so
problem or find our own problem. Modern data
right.
sets support that. Okay.
Right. So I'm not gonna necessarily be assigning assignments to you guys, right? Because I think that we are all grown ups. So like I don't need you to let me know that you have done the assignment. I would rather you try to apply the methods that we have discussed with some toy data set, right? To your own data. I think in the end of the day, like you really learn something when you're trying to solve a real problem, not just trying to like go through like some bullet points that I'm gonna list to you. You see? And you guys are aware that you also have to present a project, right, in the end of the course. So like I think that the ideal way how you can make use of these things that we're going to be learning together is essentially like always bringing back to like what you'd like to use machine learning for on your own work, right? And then we're going to help you to go through that, like how to make use of these techniques to solve a problem that you're facing right now on your PhD or like on your job, right? So I think that would be basically the assignments. It's like how you can apply the things that we're discussing to your own work.
Great.
Yes, Tony?
I have another question actually. So what is the level of the Python knowledge that you expect? Is it up to like maybe data analysis or like data visualization? Because I've not worked before with like machine learning and Python, but rather more
Right.
comfortable with the, yeah.
No, yeah, I don't expect you to know machine learning. I think that it would be more in terms of like, for example, some of the packages that we're going to be using heavily, they are the sklearn or sklearn, right? That's one that's like a pretty basic one. It has several of these functions that we're discussing here. For example, SVM, PCA, simple linear regressions, they are all implemented there, right? So like if you're comfortable using such packages, it'd be great. We're going to be using NumPy a lot, right? The corresponding version of NumPy for machine learning would be like Torch. So like we're also going to be using Torch quite a lot, like the idea of tensors, you know, and then everything else that's basically like simple syntax knowledge, right, about Python. So like I feel comfortable writing a little piece of code that loads some data and does a plot, right? I think those would be like the minimal skills needed to follow the course in terms of Python. Okay, I have 2 more minutes. Any more questions? If not, it has been great to get to know you guys
There's one
very
question.
briefly today. Oh, yeah,
Antonio, one
go ahead.
question. Yeah.
Yeah.
More of a suggestion. Maybe we could on the Discord channel or something have a channel where one can add suggestions of things that might be or comment on the lecture. So if one has some knowledge that one thinks others might not have or that might be useful for understanding the lecture better, one could just add it there. And
Perfect, and Anastasia. That's why we set up Discord as a channel for communication between us. So if you didn't do yet, anyone set up the Discord channel, the link is provided. Actually, I'm going to send a new one because the previous one has been expired. So if there was some issues, I will post it, a new email with a new channel Discord.
That reminds me, thank you, Anastasia, for the comment. One other comment I want to make is if any of you feel that the course, the pace of the course is problematic for you, please do reach out to Giuseppe or to me, and we will try to help you either by giving you supplementary material or to make some accommodations to make sure you get the most from the course. So at any point during the course, do feel free to email one of us. And we'd appreciate your feedback as well, if you have any feedback on the way the course is running for you. Thank you.
Great. So I'm gonna sign out, but yeah, feel free to shoot me an email if you want any extra information. Okay. Thank you, guys.
Thank you very much, Antonio. And before to go for a break, I give the word to Francesco Vergine. I've been knowing Francesco for many years as a friend, but also as a developer as a computer science with heavy knowledge in computation and programming. Francesco, the floor to you.
Can you listen to me? Okay, let me share the screen.
And of course, all the presentations are already in the syllabus. You can see the hyperlink in the lecture of today.
A bit slow and
Yeah, you can go, Francesco.
sharing. Oh, it's okay. Oh, this one. Okay, can you see the presentation?
Yes.
Yes, perfect. Yeah.
Let's see. Okay. So these are my introductory notes about my role in the course. So these are my reference to contact me. But anyway, I will share the Discord channel in order to be reachable by all of you. The second one is a Mastodon contact. The third one is my account on GitHub. So what is my background? I'm essentially a computer scientist, but I'm also a researcher in remote sensing and geospatial processing since I think 20 years or so. I started as a Debian developer in 2000. For people that are not so keen about Linux, Debian is the basic distribution over which is based the Ubuntu. Ubuntu is a Debian derivative as a Linux distribution. So much of the packages and libraries and tools that are available in Ubuntu are basically derived from the Debian archive as a snapshot for each release of the Ubuntu since I think 2005. I'm also the founder of the Debian GIS project. That is a sub-project of Debian dedicated to packaging and distributing for deployment. All geo tools are currently available on many of the distribution, including Ubuntu. I'm a geek and a contributor to free and open source software since the 90s. So this is the brief story of Debian GIS. We started by collecting all required stuff to run free software dedicated to geospatial information, starting from GRASS to GDAL and many others. This is the main archive dedicated to such kind of software. and rendered possible today to use in the cloud, essentially all the stuff in the easiest and clean way, without great problems in doing compilation and such things like in the previous years of the last millennium. So what I will show to you, this is ongoing anyway. I intend to present basically at least Rasterio and Google Earth Engine user and other packages used for usable from Python, and a few modern dev tools. That's because mainly when you will have to move to a cluster, you will have to essentially make a sort of deployment of stuff, but for your data, and make sure that all required dependency and tools are properly installed and usable within your environment. This is something that often need to be done even in commercial providing clouds, but it is always required when you run your stuff from premise systems or clusters. What we will see is a few packages that are useful in the context of Python to perform such kind of tasks that are basic data analysis, visualization. Antonio will present you machine learning and deep learning, a few image processing, basic image processing, and we will talk also about something that relates to computer vision and NLP, but it is very off track for what are the goals of this course. As you probably know, Python is a general purpose language. So in the time during the last 20 years, it has become one of the main data language dedicated to data science and geospatial science specifically, by means of a few well-known packages that have been developed in the last years, that include NumPy, SciPy, SymPy, and Pandas mainly, but also for the part dedicated to machine learning, the already cited TensorFlow, Keras, PyTorch, and scikit-learn. For the context of computer vision, are often used as scikit, image, and OpenCV, but also Pillow, which is the current Python image library used for general purpose operation. You can think to operation like edging and many other operations that can be performed on images. But for that, in data science, often I used some toolkits that are usable to contact external services. For instance, requests as beautiful soup or regex as tasks are often used to get your data from external services. Before that, we also see that some protocols such as the StackWAN is also currently available to gather your data, but often agency services and external services are not able to share their data using Stack. So you often have to use specialized APIs that are required to gather your data in generally in massive form. That is, when you have to just download 2 or 10 images or raster or data sets, you can rely on interactive services such as those available under Copernicus systems, for instance. But when you have to download massive quantity of the information, massive quantity of data and rasters, you have to use something that very different, as API and write your code to get those data. For the visualization, the packages used are typically Matplotlib, Seaborn, Plotly, Datashade, MIAVI, and also for 3D representation, ParaView, backend out there. Sometimes you can also be interested in preparing your own dashboards. And so you can use Dash, Streamlit, Voila Panel as packages usable to create your own application. But for that, in geo computation are generally used GeoPandas, that is the pandas for geospatial data, Cartopy, GeoPlot, Volume, IPy, Leaflet, Always, Kepler, PyDeck, Shapely, Rasterio, GDALIAN, GeoEPRGEO, and many others. They are all available in common archive for distribution, but you have to stack them properly in order to download them, get the data and represent them and convert in the required data sets for your computation. A completely different context is that of the data cubes. They are generally dealt with PySpark under Apache Spark. Can use Xarray, data cube by cube, Open Data Cube, or Raspberry Pi on the basis of what is the service they are going to use. Generally, those packages are based on the use of some kind of infrastructure that you need to access by and of course prepare. So generally, this is not a task you are to perform, but generally you use a cluster or a cloud service that is available to be consumed by those kind of packages. And so you have to learn these kind of packages and libraries just to perform big data analysis when you have to deal with long time series of raster data or even vector data, which are not available on your own hard disk, but it is available on third-party services. These we will see some of these packages during the course. So I have a couple of lectures about some of those stuff. And again, the approach will be to use code and understand the basic of some packages. You have to think as a conclusion about the Python universe, for the Python universe of libraries and packages, that it is always created in a layered manner. So generally you have some basic library available, this very basic one. You can consume it directly, but often you have to use some higher level packages, which is more, as I say, Pythonic in a way it is available in order to perform your task. And so learn to understand the difference among this kind of approach, which is quite different from that of people that is used to work with other kind of languages, such as, for instance, MATLAB or other languages of the same kind. The possibility with the use of Python are infinite, but you have to work in a ordered way in order to avoid to be lost in this universe of packages and find your way. And I think it's that was the last one, and I can answer to any of your questions eventually.
So as you can see from all the acronyms and name of this software and programming language, Francesco knows all of them. So feel free to reach anytime that you have any kind of problems in the computer science field. So it's going to be a good resources for any troubleshooting of computation in general. So concerning, so can you stop sharing, Francesco?
Already there.
Done. Perfect. So I'm going to share you guys. So as I mentioned, we are going to use always the syllabus as our main door, let's say portal with you guys, so you can have the presentation already over here under this link, the three of us, for myself, Antonio, and Francesco, so you can get directly the PDF. Can you hear me?
Yes.
Oh, okay, perfect. It was frozen a bit to Zoom. So concerning before to jumping in presenting yourself and following up the thesis, let's have a little break. It's going to be flexible, the break. We don't have a specific time, but more or less after 1 hour and 50 minutes, 1 hour and a half, we do 15 minutes break. So let's meet again at 30. So any time that you have plus 30 minutes. See you soon. Okay, let's resume the second part of the class. So we are going to continue on the presentation of you guys. In particular, this one is the Discord channel that we are going to use it. I think we will try to use as much as possible this one for, let's say, coding related and class related stuff, rather the general one for all their general information. I think you should be able to see perfect the same channel, but maybe not, because so maybe try to confirm if you see this one and also the general. You should have the same setup than myself.
All four.
All four, perfect, yeah. And this one mainly for programming. So we, according to the subject, we can choose it. Perfect. So now I give the floor to you guys. In particular, try to follow this little bullet point, the name, where are you coming from, and a bit of your background, personal interest, final project or PhD thesis, or in case you are working for a private company, what you are focused on. Do you have any experience in programming? Tell about your programming skills and so on. Just a few words. I know that you have been reported in the questionnaire, but it's good to know directly by you. And then what are your expectations from this training? And of course, if you have questions related to my presentation, Antonio presentation, Francesco, this is the time to do it right now, or even any other presentation, question that's related to the course. Okay, we will follow the roster. So Gabriel, the words to you. If Gabriel is there.
I am here.
Perfect.
Well, my name is Gabriel Ortega. I am from Chile, from southern Chile. My background is I have a bachelor in veterinary science and a PhD in forest ecology, forest sciences. And I am currently working in Czech Republic as a data manager in a project in the Czech University of Life Sciences. Okay, my experience with Linux. I use Linux in my personal computer since 2007, I think, or something like that. My main programming language is R, but also I had to speed up my learning of Python to be ready for this course. So now I am getting my way in Python too. And well, my interest and expectations of this training are grasping all this knowledge to try to be able to process large amounts of data that is currently my job. So I am equipping myself to be better at my job. And also I want the theory, I want to understand the theory behind some of the machine learning models that we are going to learn, so that it will be easier to continue on that path.
Okay, Gabriel,
Thank you very much.
Yeah, thank you very much. And as you can see, Gabriel is already using Linux for daily life computer work. So this is also one of the main expectations, that after the course you will be able to full working in Linux environment in your personal laptop without any problem, even for Zoom call or whatever other kind of not programming course. So we move now to Camilo. Is Camilo there? Maybe somebody already left. So we move to the third one, Tala Malik. Tala Malik, yeah, I don't see him. And now we have our friend Saverio. Microphone. You are on mute.
It's open now? Can you hear me?
Yeah.
Hello, everyone. I'm Saverio Mancino. I'm a PhD student in University of Bari, and my background is basically like I'm a geologist, and I work in geotechnologies, especially for processing geological data, like to a GIS environment. My final project, my PhD project, aims to model like landslide susceptibility worldwide using like large data sets, and I want to like improve in this set. That's why I'm here. I have a background in programming. I use barely some Java and in high school, but I just deal with some HTML, CSS, and so on. But now I'm approaching like Python, like some months before now, and using for preparing my dataset that I want to use. I'm now approaching even to Bash, some Bash commands. I never used Bash, so it's like a bit challenging, but not so hard. And yeah, that's my main aim to this course. I just want to manage this kind of tools, like modeling tools, machine learning, for my modeling purposes, like geological purposes. Yeah.
Thank you, Saverio.
Thank you.
And now we move to Anna or Anita.
Hello, everyone. My name is Anita Sbrano, and I'm a researcher at the Department of Earth Sciences at the University of Bari in Italy. I'm a building engineer, and I'm currently working on hydrological risk with a focus on landslides. I have a basic level in Python coding and Bash scripting. And I would like to know how best to use machine learning models for my study on global landslide susceptibility. Thank you.
Thank you, Anita. We move to Luca.
Yeah, hello. So my name is Luca, and I come from Italy, from Tuscany specifically. So my background is in environmental science, and later on I specialize more in ecology, so vegetation ecology to be more specific. And I'm currently a first-year PhD student in the University of Florence, and there I work on grasslands. So the main topic of my PhD will be to try to integrate both optical and radar images for the monitoring of grasslands. doing so by both crop modeling techniques, but also trying to develop some classifications as well of the pastoral resources in this case. As an experience, I barely use Linux, just in some courses. So that's something I also will, I hope I will learn in this course and to start using it in my daily routine. And more as programming languages in general, I use R almost on a daily basis, both for data analysis and GIS analysis, and also JavaScript, but mainly for the Google Earth Engine API. Yeah, so my expectation from the course is surely to learn new things, and I think, as someone said already, to try to understand a bit better what is going in the background of the analysis that we are doing, and not just merely trying to make it work.
Thank you, Luca. We give the word to Anastasia from Germany.
Hey, hello, my name is Anastasia. I'm currently studying in Göttingen, doing my master's in ecology and a bachelor's in biochemistry, where I'm going more towards bioinformatics. So that's very useful for the machine learning part. I'm currently working on my master thesis, where I'm modeling global plant diversity, first for all vascular plants and then family-wise diversity. I also started a small project on digitalizing herbarium labels, and once I set up the model, I want to evaluate those using geodata, so because they usually have some information about where the plant was collected. But that's the project haven't gotten that far yet. Programming-wise, I'm also using Linux as my personal computer. So I'm quite fine with Bash. I mostly work in Python. I also know R. I don't like it particularly much. What else was there?
Yeah, I think you cover everything here. Okay, thank you very much, Anastasia. Bonet or Anna?
Yeah.
I don't know which one you prefer.
Anything is fine, actually.
Okay.
Hello, everyone. So my name is Boni Joseph. I'm originally from India, but currently I'm doing my PhD in Germany with Technical University Berlin. So my background is basically flood modeling and urban hydrology. I used to work as a flood modeler previously before doing my PhD. But as part of my PhD, I'm more working with urban hydrology and diffuse pollution. So I'm keen on developing a tool which kind of like identify critical source areas of diffuse pollution. I do not have any previous experience with Linux, so it's my first time working with Linux. But on day-to-day basis, I work with R, mainly with data analysis and data visualization, and a little bit with Python as well. So I'm looking forward to like acquire more knowledge with the geodata and Linux, basically.
Perfect. Thank you, Anna. Sing this one.
Can you hear me?
The bit of echo. You want to try again?
Yeah, can you hear me now?
Yeah, better.
Yeah, okay. Sorry, because we are two colleagues together taking this call, so that's a call from another laptop. Yeah, so I'm Xingxuan Chen, and I'm from Taiwan originally, and then I'm now working as a PhD student in the Utrecht University in the Netherlands. And my background is geology in my bachelor, so that's since then, well, I use Linux in my bachelor with Seashell because I was doing seismology analysis. So, and yeah, that's back then my like daily basis computer comment, but then after that I don't use it anymore. But yeah, I think I have some basic about that. And then I am now doing wind energy assessment tool for my PhD topic, and that's also why I take this course. And because it's about spatial deployment, and then trying to assess not only physical impact but also like mental or like perception for the society together. So that's something also I expect to learn maybe from the course that to improve my model. And then yeah, other other maybe programming language I'm using. I learned R with statistic, so I use that in the past, but then I also don't like it too much. And I use Python for now about 5 years for my daily work. So before I worked as a researcher on environmental impact assessment, and that's my daily tool for modeling. So that's it. And then the explanation of the course, yeah, I just I think machine learning and the special like programming part is the one I want to learn. Yes.
Thank you very much.
Thanks.
Now we need to ask Asma, but I think she left. Is it? I think so, yeah. So Chiara.
Hi everyone, Chiara Aquino. I'm a postdoctoral researcher at the CMCC, which is the EU-Mediterranean Center for Climate Change in Italy. I have studied the bachelor in classic literature and then physics, and then I did my PhD in environmental sciences. I was using satellite remote sensing and also field data that I collected from forest plots to monitor selective logging in tropical forests. And so at the moment, I'm also looking at using Earth observation data to monitor forest cover and also create models of greenhouse gas emissions from forest fires in the Mediterranean basin. In terms of my experience, I've used Scientific Linux before. I don't know if that counts as well. And in terms of open source software, yeah, only QGIS. And for programming, I have used R, Python. Python is my main language right now for programming. JavaScript, but for Google Art Engine. And in terms of the expectations, so my knowledge has been gathered a bit by myself. I never had the opportunity to have a structured course. So I really hope that I can fill the gaps, especially in processing of geospatial data. I've been learning to use these libraries like Stereo, all the libraries, but not in a systematic way. And also machine learning would be very helpful for me to build models that I'm trying to study on forest cover and forest cover change. Thanks.
Thank you, Chiara. Yeah, concerning the Linux distribution, any distribution is fine. The underground is just a graphical user interface, quite different. It can be different, but the underlying is pretty the same. So Unix, Linux is a good way to go. Then we have Isam.
Hi everyone, my name is Isam. I'm originally from Morocco, but I am doing PhD in University of Tusha. My PhD thesis is about forecasting forest ecosystem services under climate change conditions. So regarding the Linux, I don't have an extensive experience with Linux, but I am very comfortable with R and Python. I am expecting to from this course the following. So I am user of Google Earth Engine, which has some scaling limitations when it comes to using, for example, big data, or when I intend to use some specific models. Google Earth Engine doesn't give the hand to those extensive options. The second interest of this course is machine learning. In the frame of the work I'm doing, I'm using process-based models. For those who don't know, is just a representation of knowledge and theories, physiological basically, and some theories are not very well understood, and the machine learning can overcome this missing point. So thank you so much for your organization.
Yeah, thank you, Sam. Yeah, you raise up a good point that some model there are also physical or process-based model, and now the machine learning is trying to help the process-based model to to come to a better prediction. So I don't know, you will see some application, but feel free also to you guys to explore this opportunity inside your field, inside your final work. Lucy, I think she left. Yes. Now we have Marta.
Yeah, hello.
Yeah.
My name is Marta. I come from Latvia, but I'm a PhD student in Estonia. My background is in environmental science and a bit of geological modeling. But now my PhD topic is basically water quality modeling with machine learning, with sort of a bigger emphasis on various spatial machine learning models. I don't really have experience in Linux, and therefore Bash is my #1 interest in this course. However, obviously everything else would be also very valuable. And currently I use predominantly Python and have been using Python for some 3-4 years, definitely.
Okay, thank you very much, Marta. Give the word to Akshay from India.
Hello everyone, so I'm Akshay Rajmanocha. I'm from India. So my background is I'm a geologist and also geomorphologist, and I have personal interest in landslides and debris flows. So I'm currently at first year of PhD at University of Silesia and International Environmental Doctor School for Polar Sciences at Katowice, Poland. So I have some experience in Linux and R, but I'm quite new to Python specifically. So I'm learning it from past some months and trying to do it. And yeah, I have I have expectations that I will be able to do much good in machine learning and performing some good models with this course. That's it. Thank you.
Thank you, Akshay. We move to Kumar. Yeah.
Can you hear me?
Yeah.
Yeah. Hello, everyone. My name is Kumar. I'm originally from Iran, and now I'm doing my PhD in the University of Utrecht in the Netherlands. So my PhD thesis is about the spatial aspects of energy system models and energy infrastructure. So basically, I try to improve the spatial resolution of energy system model for the case of Netherlands. So I'm working on the energy demand, resources and infrastructure. And this course, I think, I hope help me to use kind of clustering data, because I need to gather data and using clustering and then integrate it into energy system model. So I have a bit experience in Linux. I did a course in Python last year and I need to review it. Also, I have a good experience in spatial analysis using ArcGIS Pro. And yeah, that's it.
Okay, thank you very much, Kumar. And we move to Laura, if it's still there. Yeah.
Yes. Hi, everyone. My name is Laura Jimenez. I'm originally from Mexico, but I currently live in Chile, where I work as a postdoctoral researcher. at the Center of Mathematical Modeling, and I'm currently working on a project related to studying co-occurrence patterns of marine phytoplankton. So I would like to integrate some satellite data into the study that I'm doing and probably apply some machine learning approaches. I don't have experience using Linux, but I have broad experience using R for programming and a little bit of experience in Python. And I think I already answered the last one.
Okay, gracias. Kirat.
Hello, my name is Kirath. I'm from the US. I graduated from University of Virginia with a bachelor's of computer science in last year. I'm on a gap year now. Next year I'm going to get my master's. But yeah, my background, it was computer science. All the research I did in undergrad was data science and machine learning kind of stuff. And I specifically want to study that in environmental applications. So I'm going to a environmental engineering program next year. And I'm not too sure which one yet, but both my options are the research there is with water data. So I think in this course I could explore that. But I'm also excited to explore different research topics with doing different projects. With Linux, yeah, I have experience with Linux. I don't think I use it as much as I nearly could in like my pipeline. My pipeline is mainly just Python. So I'm excited to broaden that, with all the different libraries you guys mentioned. And yeah, I mean, interest. Yeah, I guess I appreciate you guys for making this course available, and I think it's a huge resource. I'm really excited just to meet everybody and learn together.
Yeah, thank you, Kirat. We give the word to Taylor.
Hi, everyone. I'm Taylor Mavera. I'm actually from Canada, not the US. So that's wrong on the website. That's okay. But I'm currently based at the University of Leeds in the UK. I'm a research scientist here. My background, I'm a freshwater biogeochemist. So I work usually at large scales building also kind of process-based nutrient models for cycling in rivers and lakes and reservoir systems. And so, yeah, I'm kind of coming at this project from that kind of background. I've done a little bit of machine learning that I've built into some process-based models, but I've kind of reached sort of the limit of my capability. And so I'm really looking to kind of expand what I can do and the scale that I can work at and the sort of the resolution that I can work at larger scales. I have a little bit of Linux experience kind of here and there over the years. I mostly build my models in MATLAB though. I've been kind of coming a bit more up to speed with Python, like many of the others have mentioned, sort of in the last few months in preparation for this. But yeah, basically just hoping to kind of expand my research capabilities and the models I can build.
Okay, thank you very much, Taylor. Caterina?
Hi, I'm Caterina. I'm from Portugal, but I'm currently in Italy, in Venice, doing my PhD. My background is in economics and statistics, but now I mostly do climate change and impacts of climate change. So I do a lot of studies on health impacts of exposure to extreme events, for instance. And so in that context, I've been using a lot of these gridded data sets and using a lot of, shape files and all of these to basically be able to do my analysis. I mostly work in R. I have worked in Python a couple of times throughout the years because it was necessary, but now I'm also getting a bit more up to speed with it. And yeah, basically the idea would be I kind of sometimes do it a bit brute force, and I would prefer to actually, understand a bit more how things are working instead of just like making it work at all costs, instead understanding actually what we're doing. And also, yeah, using Linux, I've only used it, to run things on a server, nothing more than that. But yeah, I know, the possibility to make some of these data manipulations faster, more efficient is something that I'm interested in, essentially.
Vale, perfecto. Caterina, thank you. Mohammed?
Hi everyone,
I am Muhammad Asif. Originally, I am from Pakistan. So my background is in agriculture engineering, like water sources engineering and water sources management. But currently, I am doing a PhD in flood modeling to develop early warning system and to avoid the communities from the flood disaster. So because we have used in past numerical models, but they have some limitation like high computation time. So that's like a objective to overcome this one, to move our machine learning models, to develop a machine learning models for with a fast performance. So, but I have like never experienced with the Linux, but I have used some a little bit experience with Python, which I have used in my master's. So right now, my expectation from this course is to develop a machine learning model to replace the numerical hydrological models with a fast performance and develop a early warning system and simulate short events and to provide good knowledge to the communities to avoid the disasters, particularly in Italy. Thank you very much.
Thank you very much, Mohammed. And we move to Giulia.
Hi, hello everyone. My name is Giulia Ronchetti. I'm from Italy, and I'm currently working as a researcher, in particular remote sensing and GIS analyst in a research institute that is called Ricerca sul Sistema Energetico in Italy, and we are dealing with energy system and energy applications. I have a PhD in environmental engineering, and during my PhD, I started working mainly in R programming language, but then I moved working in Python, and I've been using Python for my daily work in the last, I say, 5 years. I have no experience with Linux and Bash scripting, so my main expectation with this course is to learn more about that, so Linux and Bash, but also I would like to learn more to create, optimize, and more efficient scripting, because in general I learn by myself in programming language, so I'd like to learn in more systematic way to create scripts. Thank you so much.
Thank you, Giulia. And Leonardo.
Hello, I'm Leonardo Mancusi. I'm from Italy, from Potenza. I'm a hydraulic engineer. I have a long experience in flood risk assessment. I'm using and developing hydrological and hydrodynamic models. I generally use Python with GDAL and SQL to produce risk map. And I'm interested in learning machine learning techniques. Thank you.
Thank you very much, Leonardo. And we go to Nikita.
Yes, hello to everyone. My name is Nikita Murin. I'm from Estonia. I graduated from Tartu University, which is in Estonia. Now I'm working in Estonian Land Board, which is a national mapping agency, which means that we create all the topographic data. And my main task is to find any kind of machine learning methods to help our digitizers in their work to create topographical data. Currently, I'm using ArcGIS Pro. It's a user interface. Also, I'm using Python, like basic Python for making our processes in large scale for scaling and connected to ArcPy. Final project could be one of our running tasks, maybe some object detection project. I have a little experience on Linux, but only for some webinars where we used Linux commands, but so not much. Also in university, I used to work in QGIS. So yes, currently I use Python only. I'm only familiar with Python, but my interest in this training course is to be able to move from ArcGIS to open source libraries and to be able to move our projects to clusters also, to clouds.
Okay, thank you very much, Nikita. Now the last one, Maria Antonietta.
Hello, everyone. I'm Maria Antonietta. I'm from Italy and I work at the University of Salento in Lecce. I work at the Biology and Ecology department. Before coming to this field, I was working in a different field. I graduated in mechanical engineering some years ago, and I worked in Germany for some years in the car industry, so totally different. But then I decided to change career, and I attended another 2 years of university. I attended a master's degree at the University of Salento called E-Biodiversity and Ecosystem Sciences that focuses on ecological informatics and open science practices and data management for biodiversity and ecosystem research. And now, as I said, I work at the University of Salento as a researcher in this field. In particular, I mostly work on virtual research environments. And we have upcoming projects where we will also deal with the geographical data and probably also with the predictions with the machine learning. So that's why I'm attending this course to gain knowledge and be more familiar with the additional tools that I can use in upcoming projects. And at the moment, I don't have experience in Linux, and as programming languages, at the moment, I work mostly with R and Python. Thank you.
Okay, thank you, Maria Antonietta. I think we cover everybody. And as you can see, you have a quite distinct background. Your final focus of final project or field of application are quite different, but with all of you with the same focus in try to learning as much as possible the geocomputation part for the geoprocessing and also the machine learning from the modeling part. We will focus in the first part of the course, we will focus on the geocomputation, and I will mainly run in the course. Later on, we'll give the ball to Antonio. And in the middle will be Francesco to cover up some other topics. As you can see and learn from this first class, we are going to running everything in Linux because we really believe it that is the operating system where all the open source can be glued together. So in my email from last week, I was giving to you instruction how to do the installation of the Linux virtual machine. So now we have a bit of time to review this material and see how you are in this topic. So if you go to the syllabus, you can see that tomorrow we have a catch-up session, okay, where you can dealing and appearing, I mean, in the class, only if you had problem with the installation of a virtual machine. If all these points that now we are going to see together are working fine, then you can skip and you can come directly on Thursday, because Thursday is going to be going directly into the coding line and we started. So I would like that everybody has the virtual machine ready to go for Thursday. So if you have any problem, please come on this catch-up session. I'm going to send you a Zoom link because this one is set only for Thursday and Tuesday and Thursday. Yes, Luca.
Yeah, sorry, yeah, it's gonna be the same time as today, tomorrow?
Yeah, same times.
Okay.
Yeah, times net today. Thanks for pointing. And please also, due to the time, also pay attention that Antonio was busy during the time for this time, so we shifted 2 hours in advance. Actually, even more, 4 hours in advance. The class starting from the 7th of May. Okay, so pay attention that they're going to be shifted a few hours in advance, and it's going to be also Wednesday in the middle to cover up some GRASS lecture that I'm going to cover. But this is for later on. So concerning the installation of the Linux virtual machine, in my email, it was sent to you guys that over here, there are all this one. Yeah, prepare as GeoLife for spatial ecology courses. So there are all the instructions how to install it, the virtual machine. Now it's running, yeah. So over here, there are the installation of YouTube video. Pay attention, that is from 2 versions 2 years ago, but it's just the version that's changing. The procedure is pretty the same. So you can follow this installation, and then you can also go through the material for the installation that is over here. Okay, so it's going to be step by step how to do the installation of the virtual machine. So just a few words about this, the virtual machine. The virtual machine, the installation or the story of the virtual machine was born like 10, maybe 15 years ago, because the different programmer cannot have several computers with the different operating system in order to test all the different programming and distribution that they are going to cover. No, so they were using a virtual machine of different operating system to testing if the process was working fine, if their scripting procedure was working fine for the different operating system version. So, and a few years ago, I mean, not a few years ago, as soon as it was coming out 15 years ago, I got the idea to use it for developing a full course that we are running. And there was this OS GeoLive that I sent you the link, that is it was prepackaging all a Linux machine with inside the software for geocomputation. So in particular, if you never heard about virtual machine in general, is nothing else that is an operating system that is set not on top, but just in a folder, in a file of the operating system that you have, your Windows or your Mac. So in the end, it's going to appearing like a new window where it's completely a software, an operating system that is completely independent. So pay attention that I open over here also the resources that the virtual machine is going to take. So as you can see, having a virtual machine open plus the Zoom plus more or less not so much, you know, I don't have the Thunderbird for my email, Discord, WhatsApp, the document for the PDF, and that's it. I'm already 23 giga of RAM. So pay attention that the use of the virtual machine is going to use quite a lot of your RAM resources. So if you follow up the procedure in a proper way, you should have done. One second, go back. You should have arriving to these. To this final screen, and in particular, okay, second. In particular, these are the most important stuff that you are going to check if you have the virtual machine installed correctly. In particular, let's see together this point that are the point that if they are not, you should come tomorrow. So the virtual machine the virtual machine internet connection is working fine. So be sure that you open Firefox over here, you Google something, and something is appearing, okay? So you just Google something in the bar, and so my internet connection is working. If it's not working, pay attention that over here, sometimes you have over here the connection that is not coming properly. And over here in the setting of the machine setting, in the setting of the device, you have the networking that for some machine you need to shift this one, bridge adapter. So try to play in one of these in order to see if your internet work is not coming up. So this is for the virtual machine. Then quite often there is the virtual machine that, as in the beginning, is coming quite small. So it's coming like, let's say like this. And when you try to enlarge it, is remaining very small without be completely shifting the view, okay? We're covering the full view. And of course, it's very uncomfortable to work with, with a terminal very small and not having the full capacity of the screen. So pay attention about this. And if it's not working fine, again, come tomorrow, but this is due to the guest addition that is not working properly. So check in the tutorial how to install the guest addition. So this one is for the machine's widescreen. Then be sure that your /media is working fine. So in particular, if the sharing folder is working fine, you should see under /media, you should see the folder. If you did the sharing folder correctly, you should see this one. Okay, you should have seen this folder. Probably you will see something different as a file, but you should be able to access. You should not have permission denied or folder not existent or something like this error over here. No such a file or directory. So if something is coming like this, means that you didn't do the sharing folder correctly. Also, pay attention in the same way if you have the MIC data folder visible. Again, also in this case, if this is not visible, means that you didn't have done the sharing folder correctly, or the git clone for downloading the data you didn't do correctly. Okay, so these are also is linked with the previous one. Okay, and last one, but probably I should put as a first one, be sure that your keyboards, and in particular, okay, I have a United States keyboard, so over here I'm using just the default, but if you have a keyboard different, then you have to setting up your keyboards from your country, and also these are related in the link that I provide you over here in the tutorial. Kumar has some question.
Yeah, basically I followed the instruction to create this shared folder, but I think it referred to the virtual machine environment, not my local system. Should I change the path to my local computer? Because I didn't find anything in the instruction.
No. Wait, 1 second. Inside this sharing folder is nothing else than a folder that is in sharing between the virtual machine and your operating system. In other words, over this one LVM share, you have to create this folder under your operating system. So in my case, I have a folder that is called LVM shared, okay, in my operating system. That is, I have Linux with a virtual machine in Linux, okay, just to have everything with you. But in your case, it's going to be your Windows machine, so you have to create your LVM shared folder in Windows, and then inside here, everything that you will see over here pasted or create a file is going to appear directly also under here. So as you can see, the test1 is going to be test1 over here. Okay, so this is the way to see if your sharing folder is done correctly. Okay, Kumar?
Okay, I did the same, but it cannot find it, but I will try it again. Thank you.
Yeah, and also pay attention. Yeah, do it again. And also pay attention. Read carefully each single line. For example, if you do it a sharing folder and you don't reboot it, then it's not going to appearing. Okay. Or if you do the sharing folder and you don't install the guest addition that is written after, also is not appearing. So you have to try and read carefully each single step.